Okay, so in our previous class, we tried to like deploy our server and we encountered some errors. So what I actually did was okay, I never wanted us to come and start battling with that error again. So I just made I made a little change. I removed Prisma as a development dependency and installed it as a dependency both for production and development. So I removed the Prisma generates, but then I generated the Prisma before uploading it. I mean, pushing code to GitHub so our hosting service can then deploy it successfully. Okay, so let me show you what we got here. Okay, here's KodeCamp 3. Why is it taking a little bit longer to respond? Okay, so here's our server logs. It's actually listening to a request. So we can come here and then, oh no, let's just use okay, let's open it in another tab. The connection is not private. Okay, logs. So why is it showing this? Cycling with cloud. Okay, so let's just test it in Postman. Postman is taking time to. We have our variables added and every other thing. Okay, so Postman is loading. I don't know why it's taking much time. So let's just add a collection. I copy the URL. So let's send this request and see. Okay, so as you can see, it's working. We have just one task. Then if you navigate to the route and then we make a request again, we have route does not exist because we're not handling this and the index route. But if you go to tasks and then we send our request. Okay, so now we will make some changes and then add something in the index route. What we will do is, this is our index route. So we'll come here. First of all, we will create a public folder in the root, in our project root. We create a directory like public, and inside this public, we have an HTML file, index HTML. And then we generate a minimal HTML template like so. Then we'll go with an H1. We'll say something like KCTM, that is KodeCamp Task Manager. And then we'll come over to our index.js. And then before the tasks, we add another middleware, app use, and we can just add a / that is the index route. Let me see, express static. Then we pass in our public folder. Now let's start our server and check out what's happening. It's crashing that app.use, not user. Okay, so it's running now. Let's open our browser and check. Okay, we have KCTM. So now once a user visits our application, the user will see KCTM before navigating to tasks. And then the task will be available to the user. So let's add a little bit of styling to our index HTML file. You can add many things. You can add as many things. You can even add some documentation, some description, or anything you want to add at all. And then the title, we just come here and see case CTN, like so. Here we create a CSS file, app CSS. And then we just reset our files. Then we see box sizing of border box, give it a margin of 0, and then padding of 0 as well. Then we come here and we say body, say mean height, that is 100 view height, and then the minimum width should be 100 view width, like so. And then we can even move our H1 here like so, and then put it inside a div element. Then we'll come here and say div H1. We give it a color of let's say let's give it which color is nice, but let's just give it purple. Oh, it's purple, blue, violet. Oh wow. Okay, so then we see display of flex, and then we say justify. Is it justify content? Justify content center, and then align items of center. Like so, okay, so let's see if it's our styles. Okay, we've not linked our CSS file. We'll come down here and then we'll link our CSS file. Our CSS file, app CSS. Okay, so we've linked our CSS file. Let's go back to our browser and then refresh. Okay, we still have tasks showing up. Let's navigate to the index routes. Okay, and so we have KCTM, but it's way at the top. So what we want to do is, and you can make it align items. I mean, justify something or something like that. But what I'm going to do is, I will just say margin top of let's say 8 rem, like so. Then we'll come down here and then we'll refresh again. Okay. Okay, we can make it no, we can make it a font size of 5 rem, like so. Then we'll refresh. Okay, it's now bigger. And can change the background to a bit light gray, or something like much lighter one. F1, F1, F1. I think this one is lighter. Okay, so we'll come here and refresh. Okay, so it's working. So we have a light gray background and then text of KCTM. So let's push this. Okay, I've forgotten one thing. And if you notice something, we're not having any favicon, and then I want to push this and show you something. Okay, so let's see how our application will build. I think it should be deploying by now, or it will take a few seconds. Okay, it's deploying. Add public directory, yes. And it will be done in a few seconds. I think it's late and it's ready. So we'll come here. Task 200, not found. Okay. Let's see if it will work this time around. Okay, so it's working. As you can see, we have deployed it, and once you visit our index route, you will see this. And then when you come here, you will notice this thing, favicon.ico. You are seeing 4 that is not found. The app CSS is found. We can see the app CSS, the index route, but then this is not found. And this is the reason why we're not having any icon here. So we can simply come here and add an icon. I think I have an icon. Where can I get some images? Okay. Let me grab a node icon. Also node icon. Okay, let me just grab this engine X icon and then bring it down to our KodeCamp 3. Okay. And then Express Task Manager. And then drop in the public folder, like so. So back to then we can see our icon here. Then open your index HTML. Right above the link CSS, then you add link favicon. Then you remove that, and then you see engine X SVG. And then we start our server, npm run dev. Okay, so we come here and then we refresh this time around. And then we can see our icon, our favicon engine X SVG is showing right there. And then we can commit and push our changes again. Okay, so we've pushed our code, and then I think it should be building by now. Let's check our deployments. Our 19th deployment, add favicon, and it's building. It should be done in just a second or so. We'll wait for it a little bit to take at most 19 to 20 or 20 something seconds. And then we'll check, or we'll refresh rather. Okay, we'll come down here and then we'll refresh. Okay. I don't know why it's showing me that, but then come back here and then open this URL and see if we got some nice. Okay. Almost attackers might be trying to steal your information from you. I don't think that's true. Proceed anyway. I want to proceed. I should load. Okay, it's not loading. What's wrong with this? Okay, we verified our icon is working, and it will also work in production. But I don't know the reason why this is showing me not. I think it worked the other time. Okay, so that's it. And I think we've successfully deployed our server, and it's working. So let's go to Postman. Okay, Postman index routes, make a request. And then we have our HTML with, look at the favicon here, Nginx SVG, image / X icon, style sheet, app CSS. Then we have our title KCTM, then our H1 KCTM. Okay, and that's nice. And then if you navigate to, okay, let's see, app CSS. And then we see our styles. And that's so we've seen our styles. We can even navigate to app, let me see, Nginx SVG. Send request. And we have seen, look at, it's returning everything, it's serving our static files, our CSS, our favicon, and our index HTML. So that's cool. Okay. Send it. Have our HTML file. Okay. So that's it for server deployment. Okay. We've come a long way, and we should be happy for that. Okay, and I forgot to mention one thing here in our controllers tasks. Here we have, we're trying to make this work properly, but then I forgot this was coming in as JSON, let me say a JSON object. So what I will do is I will reassign it. I will say completed is equal to JSON parse completed. Okay, so now I will then just remove this, then remove this, and then we are good to go. And then here I can even say log completed, and then below log completed. Or to make it more, you can say log type of completed, and then here we also say log type of completed. And then we come down to, let's see, npm run dev. So come down to Postman here, and then we saw Postman. So http / localhost 3000 / tasks, and then we send our request. Internet server error. What's the problem? Let's check down here. Undefined. Okay, it's showing undefined. Params. Let's add some params like completed. Let's add a false to it. And then we send again. We have an undefined in a string. Okay, so let's see. You have a string and then we have nothing. Okay. So what's happening here? We log this type of completed is returning string. We'll pass this and then query queue type of completed or contains queue. It's actually a string. And then we're getting a server error. And I'm wondering what's causing that server error. Anyways. Okay, let's see. Const comp is equal to JSON pass. And then we see type of comp, and then we come down here and then we see completed comp like so. And then let's go back and make our requests. We need to, we're not concerned about this server error. Okay, so we're getting our task. So this is what I want you to see. I want you to see initially type of completed was coming in as a string. Then we pass the JSON object to get a Boolean, and then we are getting a Boolean right now. So we are safely converting it. So you should take note of all these little things. Sometimes you encounter them and they will give you a headache. And if you don't know how to get rid of them, you end up stuck in one place. Okay, so that's just it for this one. Now we can actually filter our queries anyhow we want. We can filter a query that contains, a task that contains a specific query or completed, where a user wants to mark his or her query completed. We just send a request, a post request, and then mark it completed, and just like that. Okay, so I think that's just it for server deployment. So we've learned a lot in our previous class and today's class, and we learned how to use Express with SQLite. And normally SQLite is for deployment and light applications. It's not advisable to use SQLite in production if your application will grow with time and it lacks some authentication methods. Like SQLite lacks some methods in production where you have to write data and then get data. But then using other database like MongoDB, MySQL, PostgreSQL, and gives you control over everything. And that's the reason why we switched to MongoDB, because I don't have any access to a free MySQL server right now. And I don't have money to host a MySQL database on DigitalOcean. I would love to do that, but then it's out of my control, because I would love to host my DigitalOcean Droplet, where I will teach you about HA proxies, load balancers and then reverse proxies. But then we do that locally because I don't have any droplet or any virtual machine that I can host a server and then teach all of that. But that's by the way. The most important thing is we're learning this thing. And what it's good about Prisma is it's a cross-platform ORM where you can actually use with both document databases and there is NoSQL databases and then SQL databases. So that is one sweet thing with Prisma. Okay, so and that was actually sweet. There are some things in we're talking about. I mean, some things we've learned in our course so far that you actually can't find anywhere else. Because one thing I noticed about these YouTube authors is um some of them are actually beginners. What they will do is just grab a concept, know little about it, and then jump into teaching without knowing much about that concept. And some of them will get you confused. And that's the reason why they are promoting this main stack of a thing. Main stack, I know MongoDB actually is for big data. Though you can use it for small data, but it's actually good for big data. You can use SQL database for small, but when the data becomes larger, you know, connecting and joining tables behind the scene becomes a kind of a bulky. But Prisma simplifies that. If you use Prisma with big with SQL databases in handling big data, you will be a success at that one because Prisma handles data, I mean, query optimization, and then all of that. And we'll look at that in just a minute. Okay. And the next, we're going to be learning with working with databases. Okay. So actually, we've learned that, but not in depth. And this time around, I'll try to go a little bit in depth on how to work with databases, that's SQL databases, and then the NoSQL databases. Okay, so let's jump right into that. Working with databases, here we have object relational mapping, SQL and NoSQL databases, SQLite for development. I prefer SQLite for development, and if you want to build a blog, your own personal blog, you can use SQLite where you can host it directly in your application, or you can use GitHub API where you can store anytime you write a blog post, it will be stored on your repo on GitHub. And then if you want to fetch it, if a user wants to view your blog post, the user will fetch directly from GitHub. But that's kind of an advanced thing, and you need to learn about that. But in other tasks where you want to build an application to serve millions of users, do not use SQLite. Okay, and another on our list, we have MongoDB, a NoSQL database. There's a document database. And then last but not the least, we have database performance and optimization with Prisma. There's the query optimization and then logging for debugging. We're going to be looking at that just slightly, but then later we see how we can look at that in depth. But yeah, Moses, go ahead.
Good day, sir.
Yeah, okay.
Good day. Thank you for the amazing classes. I
Welcome.
in on Discord, I posted about my question is outside this class though. On Discord,
Yeah.
I posted about you not posting the sixth and the 10th classes on YouTube. We actually need it. We only come here to listen, then we go back to the YouTube classes, to the YouTube videos. Please, we need the sixth and the 10th classes on YouTube so that we can go through it.
Okay. Um, Noted. And the fact about this is that I'm not the one in charge of uploading videos, but I'll communicate that to the admin then.
Okay, because I've actually mentioned him on Discord. He's yet to reply. I don't know. Maybe probably he has issues with uploading it. I don't know. We actually
Okay,
need it
I'll
to move on with the classes.
Okay, I'll actually approach him on that. Thanks, anyways. Okay,
You're
yeah.
welcome,
So we're going to
sir.
be starting with object relational mapping, since you are not going to be writing any raw SQL or no SQL database queries. And writing SQL queries is another broad concept or another broad topic you have to go into. And then no SQL. There is yeah. Go ahead.
Okay, thank you, sir. Please, there is a question that is bothering me since our last class. It's about
Yeah, go ahead.
the query builder and the ORM. So I'm confused. I just want to ask which one is recommended to be using. Maybe as for the NodeJS, like CNES, the CNES query builder, instead of using Objective Bookself or the Sequelizer. So is it preferable to be using the CNES library just to be at the middle? So maybe I don't want to use the ORM and I don't want to use the raw SQL query.
Okay. Next, it's a native, a kind of a native driver, right? It's not actually, it's a query builder, but it's not actually an ORM. And that's actually a good idea. If you don't want to use an ORM, you can use any query builder or something like that if you don't want to use an actual ORM. But in this case, you will not be working alone on most of these projects. Some of the projects you're working on in real life will be a kind of complex project. So if you don't want to take on any ORM, you end up messing up your code base, where most of your employees will not have any knowledge of query builders, but they will have a basic knowledge of ORMs, where you can then teach them how to use it properly. So that is the advantage of it, and it's abstract and all this database logic from your code.
Okay,
It's
okay,
it's it's actually depend on what you want to use, on what your requirements are. So you don't have any problem with that. You can go ahead and use anyone, since you can connect it effectively. We have tons of technologies out there, and I work just the thing is, you try to have a basic knowledge of all these ones, so that anywhere you find yourself, you fit in. There's the general advice here.
okay, okay. Thank you, sir.
You're welcome. So an ORM stands for relational object relational mapping. It's actually a programming technique and software design pattern used in software development to bridge the gap between object and oriented programming and relational databases. Okay, let's try to briefly explain how ORM, object relational mapping, are related to object-oriented programming. Like in OOP, data and behavior, like that is the behavior, the methods are encapsulated within objects. So objects have attributes and methods. Those methods are functions. Then the attributes are the data. We discussed that earlier, associated with them. So OOP is widely used in many programming languages, including JavaScript, Python, Java, C++, and all of that. Relational databases store data in tables with rows and columns. They use a structured query language, that is SQL, for data manipulation. And examples of um, relational database include MySQL, Postgres, SQL, and then SQLite. And then mapping objects to database tables. This ORM provides a way to map objects on their attributes in an object-oriented programming language to tables and columns in a relational database. Each object in an application corresponds to a row in database table. And what ORM does, it simplifies database interaction. With ORM, developers can interact with the database using object-oriented code instead of writing SQL queries directly, as I earlier said. This simplifies database operations and make them more natural for developers who are used to OOP and don't want to learn SQL. But it's a good practice to learn SQL. So when you learn SQL, you proceed to database design and database administration so that you need to be the back-end developer you actually say you are. But if you don't know all these things, I don't think you're actually a back-end developer that you claim you are. And cross-platform compatibility. ORM frameworks often abstract the underlying database system, making it easier to switch between different databases backend without rewriting the entire database interaction code. And an example of that is when we actually switched from SQLite to MongoDB. MongoDB using of IDs, it's a bit different. So what we changed was only the IDs and everything worked as expected. So if you're not using a cross-platform ORM like Mongoose, you have to then switch to another ORM that will support MongoDB. And then security and performance. ORM frameworks typically handle security concerns like SQL injection and help optimize queries for better database performance. So if, SQL it's a kind of, let me say, bulky to learn. For you to learn SQL query optimizations, you have to be very good at it. But when you use ORMs, everything is handled under the hood. Like behind the scene, everything is handled for you. And the code maintainability, as I earlier said, you don't want to mess up your code base. So ORM promotes cleaner and more maintainable code because developers work with objects and classes instead of writing raw SQL queries or writing documents, database queries like MongoDB and all of that. So this can lead to more readable and less error-prone code. And we have a lot of these ORMs. Different languages have different ORMs. We have SQLite for JavaScript. JavaScript has I know about 4 of them or so. MongoDB has Mongoose and Mongoose. I think that Mongoose is a kind of native driver or something like that. I don't know much about Mongoose, but I know it exists. Then it has SQLite, and then it has Prisma. JavaScript has about 4 or so. Then we have Hibernate for Java. We have Active Record for Ruby on Rails. Then Django ORM for Python. Then we have SQL Alchemy for Python as well. And I love that one. I prefer SQL Alchemy to Django is used for Django only, but SQL Alchemy you can use for Flask and then raw and then plain Python. And Python also has a native, a kind of a query builder, a native driver. Let me say native driver query builder, which is my SQL. That is for my SQL. I've forgotten the actual name. We're not dealing with Python, we're dealing with JavaScript. So that is it. And in this case, the SQLite, the reason why we're using Prisma is SQLite is for relational databases. Mongoose is for Node, is specifically for MongoDB, but Prisma is cross-platform for MySQL, SQLite, PostgreSQL, PostgreSQL, MongoDB, and MariaDB. It supports about 5 or 6 databases, and they are planning to add more databases for it to support. That's actually sweet. And from what we've discussed so far, we have a basic understanding of SQL and NoSQL databases. SQL databases uses tables, columns, and rows for storing data. And these columns and rows in a table, tables are interconnected using IDs. You can connect one table to another using IDs. There's what we know as one-to-one mapping, one-to-many, and then many-to-many. It depends on your use case. But in this case, in our application, we learn how to use Prisma with a one-to-many mapping. And when we start building user authentication and authorization, that will start in just a minute. In this, we're just going to be discussing briefly this. And SQLite And one sweet thing about Prisma is SQLite and MySQL with Postgres SQL, there's just a little difference. That SQLite does not support enums, but then Postgres SQL, MySQL, and then MongoDB, they support enums. And then MongoDB, its IDs doesn't have dashes because it will throw an error if you give MongoDB an ID that has a dash between the strings. So what you just have to map your ID to the built-in MongoDB Atlas ID. You just map it so that anytime you create or update an object, the ID will be generated automatically. And that's one sweet thing about Prisma. Prisma, it's very, very powerful and well optimized. And then in a second or so, we'll be looking at database performance and optimization, by query optimization, all of that. Okay, so SQLite, we're not going to be talking much about SQLite. It's an SQL database for development, most especially for development and light web applications. If you want to know more about SQLite and how you can back up your data, even when using it in your local development environment, you can head over to SQLite, head over to Google, make sure you read their documentation and learn how to read documentation. Don't go about reading people's whack blog posts. Some authors are really, really whack. They will just jump into one or two without knowing much about it to explain anyhow, and then leave it for you to figure it out. And then you end up messing up things. Okay. And then we have MongoDB, which is a document database. This stores data in documents, but not in tables. And these documents can also be connected using IDs. IDs are very special and unique. One document can be connected to another using IDs. It's very, very efficient. I know inquiring data from a document database, it's very, very efficient. You don't need to query any tables, or you just fetch data from a document and then associate with another document and then run all of that. You can go ahead and read more about MongoDB because it's the most popular SQL database. And then MySQL is the most popular because it's been existing for a while now, before Postgres SQL and these other ones. But in performance and then in security, I think Postgres SQL is better than MySQL, and then you can go check that out too. I'm just pointing it out to you so you can go check it out. And then we have database performance and optimization, where we look into query optimization also, but we'll not be going in depth because our application is not that large, so we don't have any problems with optimizing our queries or doing all of that. Later on, we'll see how we can optimize our queries by pagination. We don't have much tasks, but we can even add pagination to our app so that if we have like about 100 or 200 tasks, we don't need to fetch them all at once. We can be fetching 10 posts per page, where a user can then navigate to another page to have 10 more tasks, navigate to another page to have that is pagination to have 10 more tasks. And then that's it for that. Then let's say, for instance, let's query optimization here is Prisma. One sweet thing about Prisma is it handles data overfetching. And let me try to show you an example of what data overfetching is. Okay. So in this get task, you are not accustomed to UI user interfaces, but then I have experience in UI UX. There's user interface and user experience design and all of that. So in this case, when designing your UI, when you get a specific task, you want to display the details about that task and only that task. So in this case, you fetch your task. So you can also say, since you want to display only maybe the task title and description. You just come here and then you say select, and inside of this select, what you will do is you will say ID. You don't need it actually, maybe you don't actually need the ID. You just say title true, and then description true, like so. So when you fetch this task, let's open up our Postman and then go ahead and paste it out. And then we'll go with tasks. Then we'll copy this ID here. We paste it /ID, and then we'll send. We are on a free tier, and that's why it's slow. As you can see, we have a task with no ID and no completed. So it's data overfetching. If you don't want to even see your task description, you can just come here and then select only your ID and you are good to go, like so. Okay, so in this case, come here, you send your request. And then you have your task and then your title. So in this case, you don't need to overstress. Okay, let me say overstress, or you don't need to like overfetch your data, or you overstress your database. You don't need to overfetch your data. You just make a network request and then you fetch only the title of your task and then you return it. You don't need to query. Okay, let's say it's a relational database where you have to query your data and then all the tasks. And then when we start building user authentication and authorization, we'll know more about this, where we want to fetch a user with the user's task or only the user's and ID and then username also. So data overfetching. What this is actually doing is you have a database with two tables, a user and the user's tasks, and then you want to fetch a user, only the user, but you don't need the task. So you just fetch only the username and the ID instead of fetching the task, because that we have to connect, we'll make a request, we query the user's tasks and then query the user as well, which will take, let's say, even if it's milliseconds, let's say querying the table, we have 5 milliseconds, then querying the querying the user's tags will take 5 milliseconds, then querying the user will take 5 milliseconds, which will be 10 milliseconds or so. But if you want to query only the user, it will have 5 milliseconds and then your request will be completed. So that's data overfetching with just get your tags with select, and then you don't need to worry about that. And then with pagination, we do that later. And you can even use include. You can come over here and then do something like this. Here I will have include. Okay, this is an object where, okay, you can do away with this where, like so, and then do something like object includes, like so. But we don't have anything here to include. Maybe a user. If you want to, you have a user and you want to fetch a user and then you want to include the user's post, or you don't want to select, then you just say here we have post ID, or you see you have the user, you have post, then you say true. You want to fetch the user, but you want to include the user's post also. All this we considered in query optimization. But when you read the Prisma's documentation, you will get to understand and all of this. And then let's say, for instance, we want to let's stop our server for this one. We are using a NoSQL database. We're not using SQL, but then I think we have a project here that we used SQL. No project, no SQL. Okay, hold on, no SQL. Okay, let me just demonstrate it. Okay, let's say you want to rename, you are using SQL database and you want to rename your table. You want to rename your table. You will simply say npx Prisma migrate, npx Prisma migrate dev dash name, the name of the table you want to rename. Let's say you've already renamed it here in your Prisma, no public Prisma, okay. Or your DB, your schema, you've already renamed it. Let's say you've renamed this to tasks. So this is not really applied to your database. So you write a migration. So the name here you see rename table, sorry, task table. And then you don't want to apply the migration. You first of all want to see how the renaming is taking place. You say dash create only. You first of all want to see how the database is being renamed. And then after this, you just come here and then give it any name. You've already renamed it, but you've not applied it. You just write npx Prisma migrate div, and then the changes we apply and then take place. And that's all for that. Okay. So what's next on our list? I advise you go take a look at the Prisma query. For NodeJs developers, you don't need to know all of these ORMs. Maybe you know more of Mongoose, and then Prisma, because Prisma is cross-platform. And then if you find yourself in a working environment where they are using SQL, some people like using SQLite, but the best ORM so far to me is Prisma and Prisma alone. Mongoose is quite good, but only for MongoDB. And when it comes to powerful queries, writing very, very powerful queries, then no JavaScript ORM is compared to Prisma. Okay, so login. If you want to debug your code and you want to see errors and warnings, you can just come down to your Prisma, and inside of your new Prisma client, you add an object literal, you say log, and then an array of see error info query, and then warning. You just say query, and then you can add a warning, error, and then all of that. So that's just it for logging our optimization, but this not we're not going to be looking at this for now. So I think we're done with query optimization and logging. Logging is actually an advanced concept where you want to, and there's a level to all these things. The reason why I want you to know all of this is you may find yourself in an environment where you are the senior dev, because you as a mid-level or a junior dev, you don't have to be optimizing queries. Yours is to write queries and make sure you do your best, and then you open a pull request, you tag a reviewer, they review your pull request, and then they will create, if they're using Kanban board or any kind of tools like Jira or any other one, you just open a ticket for query optimization, where they will go ahead and optimize all the database queries depending on their requirements. And that's how sweet development. There's a lot of things to this, but all I'll advise you to do is research. And for me, sometimes I dedicate a day or two for research. I wake up and decide, do this today. I'm not going to be doing anything else rather than researching. So I research and research and research. And if I don't find any tangible results, like results that I'm looking for, I won't stop. I will research and research and research till I find what I'm looking for. Okay, sometimes you just have to read a 1,000-page book just to understand the concept, because you want to be good at it. Because understanding things like this, oh no, you still don't understand them. You have to be very, very good at them to understand actually what's going on. Okay, So that's it for query optimization and logging. And then working with databases, we actually discussed about ORMs, object relational mapping, SQL databases, and then no SQL databases. And that is awesome. We learned a lot. And then we even learned a little about query optimization, optimizing Prisma queries. But then we'll start building user authentication and authorization. We learn more about that. Okay, so this is Swiss. And then next on our list, we have we're still on the task manager with Express.js, but this time around it is authentication. I guess most of us have been waiting for this, and we are here. And you know the most interesting part of this? Look at this. We're going to be learning how to authenticate with sessions and then token. And then after authentication, we learn authorization so as to connect our tasks with the appropriate user, so that if you log in as a different user, you will be able to access my tasks. You can make changes to only your tasks and your tasks only. You can access only your tasks, and then you can make changes to it. And that is awesome. And we all know what authentication is. Simply giving a user access to some kind of a content, so you understand. Simply giving the user access to some kind of a restricted content on your application also. So first, I'm not going to be talking much about authentication, and later we'll talk about the best practices in authentication. And that has to do with, when talking about best practices in authentication, it has to do with system design. Or system design is an advanced course, and way out of this course we are taking. Maybe you go make this little research about system design, but don't make too much research. Learn one thing at a time. You just make sure you understand the basics of system design and what it's all about. Just have an idea so that you know, oh, when you get to meet that, oh, this is system design, this is what it's all about. And it's very important when designing a large-scale application because of caching databases, hosting services, domain names, and all of that. System design is very, very good. Okay, so now authentication with session. Okay, so now, first of all, we'll be running authentication with session, then later with token. Okay, right now you don't understand about this session and token of a thing, but then as we are coding, I will try to explain. In session, all the processing are done at the server side. The server will sign a token and then send it, a cookie, and then send it to a client, where the client will store it in the browser, in the session storage, and then use it to make subsequent requests. And then if that session is tampered with, the server will invalidate the session, and then the user will be automatically logged out. Okay, so in token and the session is actually stored in the session storage, while the token is stored in the local storage. And then let's try to elaborate on the differences between the session storage and the local storage. Okay, so now, first of all, differences between the session storage and the local storage. First of all, we'll look at the scope of storage. The local storage, it persists indefinitely until explicitly cleared by the user or the application. Like, it has a broader scope and it's accessible across browser sessions and tabs. What that means is, if you open a particular tab and you are logged in and you store your data in the local storage, if you open another tab and you make changes to that tab, the changes will reflect in the previous tab you open, because you are storing your data in a local storage. But session storage is limited to the duration of a page session. It is accessible only within the tab or window, and is cleared when the tab is closed or when the session ends. Can you hear that? it's actually cleared when you close your tab, or when the session ends, or when you close your window. Then the storage limit, the local storage offer more storage space, like 10 MB, while the session storage, it has a smaller capacity compared to local storage, typically 5 MB. Take note of all these things, when to use local storage and when to use session storage. Okay, so data persistence. So local storage persists across browsers, across browser restarts, and then even when the computer is rebooted, it is suitable for storing long-term preferences or settings, while the session storage is temporary and lasts only as long as the user's session. It is ideal for storing data that is needed for a short duration, like data during a user's visit to a website or something like that. And then we have many others. Both local storage and same storage store data as key pair values and all of that. Okay, so without talking too much, we actually jump into authentication with a session. Okay, so now let's go into our web browser, then we'll close all these files. Then we'll start working with, and before we start, we'll organize our file. Here, we'll first of all go to our routes, our controllers. And inside of our controllers, notice we're going to be using this app for everything, for both authentication with session and then token. So what we will do here, we will try to differentiate this. We have session auth JS, not JSX, JS. I work a lot with React, so I make mistakes of writing JSX. And then we have another file, token auth JS. Okay, so instead of this session auth, let's just make a single function like const register, and then it should be just a function that returns an empty object. Okay, now in our routes, we make two files, we create two files. Sorry, session auth JS, and then another one, token auth JS. And inside of our session auth, we import express from express. You see const router is equal to express router. You see export default router, and then we see router post, like so, and then register. We actually did not export this. Export register. Then we'll come down here and then say register, which is coming from our controllers auth session JS, like so. Okay, then we'll come to our index file, and then we say we want to we place it on top of tags, because a user will have to be authenticated before accessing tags. So learn how to arrange your middlewares, and it's very simple. Which middleware do you need first? Place it on top of the one you need last. Okay, we say app use our application middleware, which is a session. This is session auth slash, and then let's import our here. Import session auth from routes slash session auth JS, like so. Then we'll come down here, then we'll place our session auth here. session auth. Okay, and we are good to go. So in our controllers, come here and then we log hello session, and then let's go start our app, npm run dev. Come down to Postman, and then this time around is session auth slash okay. Now when I want to make a request, I just discovered I made a mistake here in our session auth slash register, like so, because we have a register and we'll later have another one of login, like so. And then we'll have a login here. And then let's comment it out for now. It will come here, auth slash register, and this is a post request. And then we'll send it. Okay. We have hello session, but we're not handling it. So it's a kind of making this request continuously. Okay. So we cancel the request. Then we come down here. We have it's actually working. So we first of all need to implement our session and then all of the session logic. Okay, it's going to be a long walk. So first of all, we need to install Express session. Okay, so let's stop our server. npm I express session, and then is it taking time? Why is this still okay? Okay, we've installed our Express session. Okay, so now we come in our application and then we enable our session. So we have a middleware here. We just come on top of this. We will see app use session. No, app use. Okay, after we installed our Express session, we come here and then we import it. Import session from Express session, and then we want to use our session in here, app use session, like so. And then in our session options, it's actually an object, and then we specify, first of all, specify our session name, which is let's say KCTM session. And if the session is stored in the browser, this is the name the user will see in this, sorry, session. This is the name the user will see in the browser, KCTM session. Okay, so we need another one, which is secret and some gibberish. Okay, we will modify this in a second, but then let me finish with this. And then we have receive or false. We explain this. Let me finish with it first. We explain everything bit by bit. Then save on initialize. Then we set it as false as well. There are some cases where you need it to true. You need to set it to true, but we'll talk about that. Then you decide. The cookie. Remember, I said we'll be explaining this bit by bit. And then this cookie, we have secure false. Then we do that in a bit. Secure false. And then the max age, we set it to 7 days. We have 60 seconds times 60 seconds, which makes a minute. Sorry, 60 seconds times 60 seconds times 24. which makes 24 hours, and then times 7. 24 hours times 7 is 7 days. Okay, that is the cookie. We want a user to be automatically logged out after 7 days if the user is still in the browser working on what, I don't know. Okay, and then in the store, we specify a store. The reason why is because the express session, the store, the inbuilt store for the express session is only used in development, and in production there'll be memory leaks if we use it can only handle a little amount of request or a little amount of load. You know what memory leaks are? Where an application or an application fails to reallocate or free the data allocated to a piece of should I say a piece of data. You know, when working with applications, when you allocate this to, let's say, const 1 is equal to, sorry, const n is equal to 2, and then you say log n. So after logging that n, the 2 is still here, but without running, we need to in programming languages like C, you do that manually. You use the free to free the memory allocated to a piece of value, because when you create that too, you allocate it a memory of integers in C are allocated to 4 megabytes. Yes, 4 megabytes. Sorry, 4 bytes of data. So in JavaScript, it depends on the machine. Sorry, the environment the runtime environment you are using. It's either if I'm using V8 or this one or that one. It depends. The PhD uses 4 bytes for integers as well, I think, and all of that. So in simple terms, memory leak is when a program fails to free the memory not in use. So it leads to memory leak. And in time, let's assume you made that mistake and you fail to free a memory that is not in use, and you have millions of users in your application, and all of them running that application. When you get to that point, that memory is not, that memory space is not freed for other parts of your application to use it. You know what will happen? You are using more resources than required, and you run out of memory definitely, because by the time you have millions of users and you allocate 4 kilobytes of memory unit to a specific value, and then you fail to free it when not in use. Just make that by yourself. 4 kilobytes times a million. You know what that's, that means. Convert it to megabytes or terabytes, and you get to know your answer. Okay, so now we'll be setting the store in a minute, but then for now, let's explain this in depth. Okay, so we'll be starting with the name. And as I said, the name is the name of the session. This session you've created, this is the name is the name of the session cookie that will be set in the user's browser. In this, and it's in our case here, we've set it to KCTM session. So the secret here, the secret is used to sign the session ID cookie. Like it's add a layer of security to your sessions by ensuring that the session data has not been tampered with. Make sure, and you have to make sure you keep this secret value confidential. Do you know what? When a cookie is sent to the browser store it and use it to make subsequent requests. And if any modifications have been made to that cookie, when it's sent back, your server need to use your secret to, like, let's say, decrypt your cookie and then assign new data to it and then send it back to the client. So it's a kind of use symmetric kind of encryption, where it uses one key to encrypt and decrypt. Okay, you have asymmetric and asymmetric. I mentioned that in one of our classes. You go check that out. And then we have the save, which is set to false. It means that the session will not be saved to the store if it hasn't been modified during the request. And this can improve like performance by reducing unnecessary writes to the session store. Okay, let's say you made a request, a get request where you get your data, but then you did not modify anything. Let's say you did not reset your password, you did not change your username. Actually, the token will not be changed. It will not be reserved. But if you modify data, definitely the cookie, sorry, not token, the cookie will be modified, and then it will have to be received to your database and to add those changes you've made. So that is the receive. If you set your receive to true, every time you make a request, even if the cookie is not modified, your session, sorry, every time it is not modified, it will be received again, and then making multiple network requests to your database, and that's not sweet. And then save on initialized. When set to false, this ensures that sessions are not served for requests that do not modify the session data. The reserve is for the cookie, while the save on initialize is for the whole session. It's not that sessions are not served for requests that do not modify the session data. This also can help reduce the storage space and improve our performance as the receive. The receive, it means the session will not be served to the store if it hasn't been modified during the request. The save on initialize, it ensures that the sessions are not served for requests that do not modify the session data. Okay, let me go over it once more. The receive, the session will not be saved to the session store. It means this will not be saved to the store if it hasn't been modified during the request. Store, not database. Then the save on initialize, it ensures that the sessions are not set for requests that do not modify the session data. Okay, I think we've gotten that clearly. And then we have to maybe go over it again. And then we have the cookie. This cookie is an object that configures options related to the session cookie. And if you want to know depth about cookies, you head over to MDM docs. The secure here, the value of secure simply means this is only used in HTTP secured. So in development, you set it to false, but then we'll see how we can work around and then set it to true when in production, and then false when in development. Okay, so the max age is the maximum age that's in seconds for the session cookie. And in this case, we set ours to 7 days, which is equivalent to 1 week. After 1 week, the session cookie will expire and the user will need to log in again. Okay, so the store, this defines where the session data will be stored. Okay, this store here. So now we need to our secret here will come to our environmental variables, and then we'll make something like session secrets, which is equal to KodeCamp task manager, like so. Okay, then we'll go back to our node session auth, our index, and then we see session secret is equal to process env session secret, like so. And then we'll come down here and then we'll say secret session secret, like this. We want our session secret to be very, very secret. Okay. And now, what can we do about our the, 1 st, 2 nd, 3 rd, 4th, 5th, 6th, 7th, 8th, 9th, 10th, 11th, 12th, 13th, 14th, 15th, 16th, 17th, 18th, 19th, 20th, 21st, 22nd, 23rd, 24th, 25th, 26th, 27th, 28th, 29th, 30th, 31st, 32nd, 33rd, 34th, 35th, 36th, 37th, 38th, 39th, 40th, 41st, 42nd, 43rd, 44th, 45th, 46th, 47th, 48th, 49th, 50th, 51st, 52nd, 53rd, 54th, 55th, 56th, 57th, 58th, 59th, 60th, 61st, 62nd, 63rd, 64th, 65th, 66th, 67th, 68th, 69th, 70th, 71st, 72nd, 73rd, 74th, 75th, 76th sorry, our cookie, our secured cookie. We need to set it, let's say, we'll say, let's get the environmental variable. And if we are in production, then it should be secured. This will return true. But this is a comparison. If it's in product, because now we're in development, we get the environment and we see that we're in development, we return false. So we just come here and then we write, we put in our end variable like so. So we get to production, the secure will be true, and then we come to development, it return to false. And then we can make even our session cleaner. We can then cut this out like so. Extract this from our session, then come up here and then assign a cost session options is equal to like this. Then we come down here and then we put in our session options, and this is way cleaner. Then you can even move this out of this file and then add it to somewhere else where you can even import it and then use it. But let's just keep it like this. Okay, so now we can go ahead and make requests, but then we need a place to save our session, because we are pushing our app to production and we need to learn to use all this in production. Okay, so now what we will do is we will install, we have for MongoDB, we have Connect Mongo. For SQL databases, Postgres, SQL, MySQL, and SQLite, we have Connect Session Next. I can see you mentioned Next the other time. Yeah, this one is Connect Session Next, where you will do something like this. We're not using SQL databases, but then I want to show you how, if you're using, you can head over to the Connect Session Next documentation, where you can do something like import next session store from connect session next, and then down here you will do something like, you see const next store is equal to next session store, and then you pass in the session to be saved, and then you will see down here, you come down and you see const store is equal to new next, like so. And then you come down here where your store is, and then you pass in your, you use ES6 syntax, you pass in your store. Or if the, let's say the name is another thing, you see session store like this. Or if, well, let's use ES6 syntax where the name is session and then the key is session and the value is session. Oh, sorry, the key is store and the value is store. We'll just place it here. But in this next, you can provide options like the URL, the host for your, you can provide only the URL, you know, in MongoDB, you can just provide the URL. So if you don't have the host, if you are hosting it remotely, you can just specify the URL of the database. You have MySQL / something like that. And then this is how to configure next in your, but if you are using SQLite, no configurations, just pass it like this and you are good to go. Your SQLite database will work because it's configured by default. It supports SQLite under the hood, but using Postgres SQL, MySQL, you have to add additional configurations to this. So this is how to use next. Okay, so if you want to configure next, then you just do something like that. Okay, so we're not using next, we're not using any SQL database. We're using MongoDB, Mongo. So what we're going to be doing here is we will install Connect Mongo in this, before you use connect session next, you have to install it, npm I connect session next. Okay, but we're not using that. We're using MongoDB. So what we're going to be doing here is we will say npm I connect Mongo, like so. Okay, it shouldn't take much time. I connect Mongo, and then we can come here and then see, where should I do this? Okay, on top, we say import Mongo store from connect Mongo. And then you can come down here in your store and then uncomment this, you say something like Mongo store dot create. Mongo store create. Then we have an object, and this object we take in two things or more than two other advanced configurations, but then we just need two. And then we have the connection, sorry, the connection, sorry, is it the connection? No, no connection. Mongo URL, like so. And then right here, we'll come and then we'll say something like const database URL is equal to process env database URL. And let's see if I'm not mistaken. Database URL. Okay, that's sweet. And then we have that. We have database URL here. And then where do we want to save our session? We want to save it in the MongoDB, and that's why we are specifying this URL here. But then the document, and then the collection name in the document database, we don't use tables, but we use collections. So the collection name should be session. It should be stored in a session. Okay, so this is our configuration. And then we can come up here, right above this. We can even extract this. Then you can say const Mongo store is equal to this. Okay, it's equal to this whole function. Cut it and then paste it like so. Okay, I'm getting an error and then it's here. Then you say Mongo store like this to make your code more cleaner. And then you come down here, see Mongo store. You see session options. Okay. Then you see env variables, environmental variables. And you can notice how I'm importing my modules. The third-party module first. The ones in our node modules, we import them first. And then we import the ones we are building. The ones we're building, the custom ones we're building by ourselves. We import them last. If we're using the inbuilt, you first of all import the inbuilt, then you import the third party, then you import the ones you're building by yourself, so as to enable JavaScript perform to its optimal what should I say, level or something like that. Okay, so we have set up this, and then you can see our session here is then you can see application level middlewares. But it's not advisable to write this kind of comments in JS docs like this. Then you see application level middleware. If you want to write comments, write it like this. Don't do what I've been doing like this. You see session options, and then you should correct the rest by yourself. You know, do not write comments in your code like this, except where you need to, or it's unofficial. You can write it, but in an official code base, write your comment like this, like so. Don't write the other way around. Okay, so now it's time to let's implement our register functionality. Let's come down to our controllers, and then we'll first of all we'll import status codes from status codes. Then we import our async wrapper from our async wrapper JS. And then we will cut this. First of all, do away with this one. Do away with this as well. Then say async wrapper. Yeah, and then say async. Then paste this inside our async. Okay, then we'll have our request and our response object. And then we'll go ahead and then we'll log our request object body to make sure it is working as expected. Okay, let's come over to Postman, and then our body. Okay, in our body, no, it's body, not body raw, and then JC. Okay. Go here. I'm not going to be using image because we don't want a user. And throughout this course, we're not validating emails. We're not using emails or anything, but I just want to point this out. If you're using emails in your application, you need to have an email service that will confirm the user's email, because we don't want the users to fill up your database with fake email addresses. So you have to something like Node Mailer or any other services that after registration, before the user can access any other data, the user will be redirected to his or her inbox to go and then verify his or her email. So if the email is wrong, the user can access anything, and we have to use a valid email. That's the reason why we're using username here. Username. And then we see, let me say Chris. And then we have password of KodeCamp. And then let's send our request. And let me check out the response. Oh, the server is not running. Okay, let's run our server npm run dev and expect not to get a kabli. Okay, things are not breaking. Okay, and then we send our request. We're not handling anything. So let's cancel it and then check our terminal. I'll have Chris and password. Okay, so it's working as expected. So now, before we continue, there are a lot of things I'll be pointing out to you, and anything I point out to you, please take note of it. I think you should even come along with the books, or the videos are there for you on YouTube to watch, but please take note of this. In everything you want to do, in every function you want to write, in every piece of code you want to do, please, first of all, write pseudocode. If you don't know what pseudocode, this is another task for you. Go and research what pseudocodes are. Write pseudocode. And then secondly, craft a flow chart, like draw a flow chart for that function or that piece of code you want to write. If it's a bit complex, either a kind of functionality or so, please create a flow chart for it. And you know what that does? It's simplify your ability to like, it makes you reason better and make you solve problems better. let's assume you want to write a function that adds two numbers. Then you create a flowchart. Say one, the function should take parameters of a. Let's say you want to write pseudocode. Let me just write it anyhow. My function, okay, let's say the add function. The add function should take two parameters of a and b, like so. A and b, say two. And then you opt in defensive programming. Then you say, if either of the parameters is undefined, just return a string. Return a string specifying that all the parameters must be passed as arguments. Then 3. Another way you can go about this is you can opt in one of those, you can opt in assign or default one of the parameters to 0. And then you can say add these two numbers and return the result. Okay, but then we are missing in if either or both of them, both of the parameters are undefined, return a string specifying, and then you can go ahead. Now you have your pseudocode, and we don't have any flowcharts, but at least this gives us a better idea. Then you have a function of add. Then you have your a, b. Okay, now go to step 2. If either, so you say if a, like this, if a or b is exactly, or you can say if a or b is null, it's undefined, there's no value assigned to it, you can say return or arguments must be supplied or something like that. Or you can even come here and say a equal to 0. And then you can say if b is undefined or something like that. But this a that is equal to 0 can be reassigned, and then b can be also, okay, you can say equal to 0 and then b equal to 0. If you don't want to handle it like this, you can do something like this, so that if no value, 0 plus 0 gives 0, and then if 1 is passed here, 1 plus 0 will give you 1 or so. But defensive programming, let's make it like that. And then you come down here, and then you see return parse int a plus parse int b, like so. This is a kind of defensive programming. You can see this function is not as simple as you thought it was, because a user can actually pass in a string, or you can even handle this. Then you can say, or if, or type of a is equal to string, and then type of b is equal to string. Or you can even say if type of is not a number, it's not a number, you can handle it anyhow. But this is a kind of defensive programming where you just come in and then write something like this and then pass in a plus b. As you can see that the function is growing bigger because you are kind of following a better pattern, defensive programming. So this function here is minimal, but then when you follow all this and then you validate everything, your code will never fail. So that's a kind of a better programming style. Always encourage defensive programming and make sure you write a pseudocode up. And testing. When we get to testing, I will teach you how to use Mocha to test plain JavaScript. and then use it to test, use it with super test to test our APIs. Testing is very, 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 very important. Should I say very? In fact, 101. If there's something like 1000% important, okay, we'll discuss that later. Okay, so in this case, we want to implement our register functionality, but then we will encourage defensive programming here as well. And then later, we will see how we can use Express validator to simplify our logic, or so something like that. Okay, so in here, we have our request and our response. So what we do here, we say const. We're passing in a username and a password, which is equal to request body, like so. So in our request body, let's stop our server. So you cannot be starting and stopping anyhow. We don't want that. So first of all, we check if username or password return. See why we are using return here, because if you just use res like this, dot, it will not, there will not be any effect. You must use return. The function should return, because this function is inside of another function. Return this and pass it to the outer function to execute it. It's a kind of a closure something. Okay, so return res status status code but what's this? Oops. No, HTTP. Okay, status codes bad request JSON, and then you can specify a message. The reason why we're always passing in a message is because we want and I've actually been following a kind of a bad practice, and that's not encouraged. And in this authentication, what we only need is a message, so we don't need data. But in our tasks, we will modify that in a second. And then here we'll say message is invalid credentials, like so. Okay, invalid credentials. And then we want to check for the username length and the email length, because we don't want someone to enter a one character email. So we say if username length is less than, let's say, 5 characters, we return. Oh, okay, we're not supposed to be doing this, and we're supposed to be using our custom import custom error API JS. Okay, so here we'll just we're supposed to throw or return. Okay, in this case, my head is whining. Let's check what we've been doing with this. Okay, we've not been using it here actually, but we've been throwing something, I think. We've been throwing something. There's a place we used it. Okay. His name is not correct. Session. Okay. Then we'll come here and then we'll throw error, custom error API with images of invalid credentials, and then status codes dot bad request, like so. Okay, and then we'll come down here, we'll throw this one, throw custom error API with username must be at least 5 characters. And then we check for password as well. Then we see password length. If password length is less than 6 characters, we see password must be at least 6 characters. Okay, this is a kind of a defensive programming. You don't want users to do anyhow. So if you do them anyhow first of all, validate their info. But the funniest thing is we've not modded our database. So how are we going to do this? Okay, so let's come back to our Prisma folder with our Prisma schema here. Okay. Now we have our task. Now we want to add another model, the user, model user. And then the ID will be a string of, this is an ID. We want to make it a unique identifier. So we want to give it a default. A default value should be auto, the one the Prisma uses. And then we want to map it to our MongoDB object ID like this. Then the user will have a username, which is a string. Okay. What is this? Am I going to be viewing Prisma one technologies? Okay, which is a string and unique. We want to make it unique, like so. Stop showing this thing. Then we'll have a password of a string, like so. And then the user must have tasks. This is what we want to assign. We have tasks. Then we already have a task model, then an array of tasks. But if you hover here, say, but if field task is model user, the relation field task on model user is missing an opposite relation field on the model task. So we need to come here and then we'll add, see, task, okay, user ID. Each task user ID will be a string with an db.object ID. Is a string, is a string db.object ID. And then this got updated automatically. But here then we want to see user. We want to make it lowercase. This is a one-to-many. I have a Prisma extension installed in my VS Code. So this got updated automatically. So we want to identify the user in every post. The user ID. Here we say we relate the user and its task with the user ID. Relations fields, the user ID, the references. It should reference this user ID here, should reference this ID, the ID of the user. This ID of the user here should reference the ID. And the fields that want to reference, want to attach the ID to is the user ID. So when you check out this in your queries, you will see ID, title, description, completed, and user ID. And the user ID will be the ID of the user that created the task. So here we are just relating the user and the user task. Okay, I'll also repeat this again. Check out the Prisma documentation. I do have the user ID, username, password, and the user tasks. Okay, now maybe you don't have to do this, but let's do it. npx Prisma db push. I don't have to create any migration because this is not an SQL database. It's a document database. So we'll just npx Prisma so that we'll sync our MongoDB, our Prisma model with our can you see applying, as you can see, applying the following changes: collection user, unique ID, username key, username 1. Okay, your database indexes are now in sync with your Prisma schema, done in 4 minutes and 97 seconds. Generated Prisma schema and all of that. Okay, take note of all of these things. When you know when you are using an SQL database and a NoSQL database. So let's return to our session. Okay, so now we want to actually authenticate our user. We're all following. Let's not get confused and weird. Okay, so we want to check if the user already exists in our database. So we say const old user is equal to database. Okay, let me even import. We're not importing it here. Okay, we say import database from lab Prisma.js. Okay, we say user equal to await database that user was find. I think we've made the username unique, but we need to find first for query optimization purposes. Find where username, and then we say if there's an old user, we simply throw custom error API with a okay, we say something like let's give them a valid message that will tell them something. Okay, we say user with username already exists, something like this. And then this should be a bad request. It's actually a bad request. Then we say status code bad request, like so. Okay, and if the user is found, we want to tell them that the user with the username, because we want usernames to be unique so that we can use them to identify users in our database. And then we'll come back to our Prisma schema, and then we'll make a little change. This will be password hash, because we're not storing plain passwords in our database. And then we'll run something like npx Prisma db push again. Okay, and then syncing our the data is already synced with Prisma. Sometimes it happens like that. The data is already synced with what to blah blah blah. Okay, now let's come back to our controller here, where we are checking our user and all of that. So now that we've notified them, the user now they will try to use another password and then send the request. So if the user is not found, we want to actually register them and add them to our database. You see const password hash. Is it hash like no hash? I hope I didn't write that hash there. Okay, password hash, and this is where bcrypt comes in. I forgot that I did not install bcrypt. Okay, bcrypt, we don't have enough time now, but later maybe we'll talk about bcrypt in our next class. Okay, so we'll install bcrypt to hash our passwords. npm I bcrypt js, like so. So we'll come up here and then we'll import bcrypt here. Import bcrypt from bcrypt.js, and then we'll come down here. This is equal to await, then bcrypt hash. I can see it requires a string and a salt. Then you can hard code your salt because it will run rounds. Asynchronously generate a hash for the given string. Then we'll say our password, and then we need to go 10 rounds to generate. This is very, very heavy. There's no way you can decrypt this except decrypt algorithm. Decrypt uses a asymmetric kind of method. It's not like express sessions that uses symmetric. This uses asymmetric kind of okay. That's it. Go and make a kind of research to understand the symmetric and asymmetric. So now that we've hashed our password, what else do we want to do? Then we want to save the user to the database. Then we will say await database user create, then we give it a data, give it the data of our username. We use the ES6 syntax, username, and then password hash, like so. Then after creating the database, we don't want them to access anything. And then we create a middleware later that we check if a user exists. So right now, what we want to do is we don't want to return the user password. So we can actually make a function here that then takes the user and then returns only the user. Okay, you can say function. You can say serialize user, and then that takes in the user and then actually return something like ID, user.id, and then username, user.username, like so. Or if you don't want to do that, we can come down here, create, see, select ID. That's one thing about Prisma. If it's Mongoose or other ones, you have to write that function and then username true. You don't want to return the password. You don't even need it. Okay, say let's come here and then comment this out first. And let's come down here. And then we've created our user. And then first of all, let's say const user is equal to await. And let's log our user and see what we've got first. User. Okay. Now it's time to run our app. npm run dev. It's running. Then let's create our user one more time. What's happening? Okay, sorry, we're not handling it. And we're having, okay, let me stop the request. I forgot we're not handling it. Okay, so our user is actually created. As you can see, we're not having an ID, the password. We're just selecting the ID and the username because we don't need the password and we don't want someone to get access to it so that the person will go and try to decrypt it and then make a request and try to retrieve the user's data. Let's say we're making transaction and we will try to steal the user credit card and then use it so a kind of a la vida. We don't want that kind of thing. Okay, so now that we have, okay, now let us log request session. Let us log our request session and then our user. So let's try to make the request now and then see what we've got. Let's try to create the user again. Internet server error. Okay. Call this. Let me just paste it here and then remove this one. Okay, let's give me an internet server error. Okay, so actually this is what I want to get access to. As you can see, we have our session with a cookie and the path is this. Can you modify this path? This path is it should be valid in the index route of our front-end application, while it expires on the 1909. Expires 1909. 12 to 2. What is today? Original max age is 604,800. Today is 19. Okay, 20. That is 837. And well, okay, the original max age. HTTP only, true, secure is false. Okay, and this is what we want. But then you can see that the session does not have a user object on it. They want to add the user object. We want to simply say request session user is equal to user. Now that the user has been successfully logged in, we attached the request user to this thing. Okay, now we can see rest dot status codes created JSON message. We say user registered. Okay, or you can say registration successful. Something like this. You can say registration successful. Is it like this or like this? Let it be. Registration successful. Created and then send registration successful. But now we're not doing anything. We've logged in, but then we have to create a middleware that will check. Okay, for now, I'm throwing this custom error API and then it's doing nothing. I'm just getting internal server error. Okay. I think I should, let me see something. Let me check something a bit. Okay, now let's make this request again. Because it's like we messed up. Okay, it's the internet server error. And the reason why is because maybe the error is not handled correctly. But let me use another username. And then this time around, let's do it once and then end our class. I want to also log session. And then before this, I want to log it here. And then log it before we assign, we add a user object to it. Okay. And we can say before, and then we can say something like after. And then let's come down here and then change this to Crystal and then make a request. Registration successful. Okay. And then we come down here. As you can see, this session now has, see after session. You can see before session, this session has no user object on it. And then we have after session. Then the session has a user with ID of this and username of this. And that is sweet. So our registration functionality is working. And that is sweet. Okay, so we are still working on the session authentication with sessions, and we have learned how to use bcrypt to encrypt our passwords, how to successfully save it to our database, and then how to return messages to the users to know they've successfully registered. But then we have not handled all the cases. Where after logging in, we will make a request to the main route where the main route will fetch the user's resources and then return it. But that will be in our next class. For today, let's call it today. And if you have any questions, please, you can go ahead and ask. Any questions? Okay, so I think no questions. So we'll call it a day and see you all in our next class.